Hello and welcome. Now let's validate the concepts that we have studied. So first of all, let's do the image blending. So here I am taking an 8 by 8 image. Then I am taking a Gaussian 1D kernel, which is converted into 5 by 5 2D kernel here. Then I am using the reflective padding during the reduction, and during the expansion we would be inserting the zeros and would be doing the interpolation. Then this is basically the main code. Here you could see that we are first converting our 8 by 8 example into 1 by 1 by going through 3 steps of 4 by 4, 4 by 4 into 2 by 2, 2 by 2 into 1 into 1. Then we are calculating the Laplacian pyramid, and afterwards we are doing the reconstruction. And our output should be exact, since this is a lossless reconstruction. So now let's run the code and see what happens. So you could see that our error is actually equal to 0, which should be. Next, let's talk about the coding. And here when I'm saying coding, I'm basically talking about the Shannon entropy. So now let's calculate the Shannon entropy and compare whether Shannon entropy is able to save the bits for us. So this is basically the code. I would be demonstrating here that it is actually the correct one. So now let's run the code. So if we run the code, you could see that entropy based coding is actually saving 20% for us in terms of the mbase. Now let's validate that the concepts, especially the Shannon one. So this is a small proof. So look here, this is actually our code. We are taking some values and we are calculating the Shannon entropy using this formulation. Here NP is basically your numpy. Okay. Next, I'm just taking these 8 values, and when we convert these values, since we are using the rounding, so based on this rounding, any value is thresholded based on 0.5. So anything less than 0.5 is equal to 0, and anything which is above 0.5 on the fractional part would be converted to the next integer. So that's why 2.6 is converted to the 3. However, if you look here, minus 2.1 is converted to minus 2 because this fractional part is less than 0.5. So we have 8 symbols, and this is basically the equivalence of this raw data in terms of the integer based values. So now we have converted or created the histogram, and you can check that all the 8 values are accounted for. Next, we are calculating the probability, and our sum of the probability is equal to 1, which should be. Now we are calculating the Shannon entropy here, and it is equal to 1.75. So in fact, by the formula, if you run, it would be giving you 1.75, which is same as the by hand calculation that I have shown you. So that's it.